So today I'm going to be talking about the consequences of Kessler syndrome and how it could affect you. The Kessler effect, otherwise known as Kessler syndrome, is a theory created by scientist Donald Kessler in the 1970s. Don Kessler was NASA's senior scientist for orbital debris research up until the mid-1990s. He has over 40 years of experience in scientific research associated with orbital debris. Despite his extraordinary advancements in the spatial debris field, his most notable achievement was the development of the Kessler syndrome theory. The premise of Kessler syndrome is on the issue of space debris pollution. Kessler syndrome is a chain reaction in which the space debris will continuously collide with other orbital debris, causing more space pollution. This is concerning because at the moment there are more than 500,000 pieces of debris larger than 1 centimeter orbiting Earth today, including 21,000 pieces larger than 10 centimeters that are actively tracked, according to science and technology journalist Neil Patel. While the small size of these debris may appear insignificant, the damage it poses to satellites is astronomical. Additionally, the number of space debris is growing each year, posing an even greater chance for the Kessler effect to occur. Alright, so I've included this slide to give everyone an idea of how bad the space pollution issue is at the moment. On the left, we have a picture of Earth as we tend to perceive it from space. However, on the right, here's a picture of what Earth actually looks like, and you can see a ton of orbital debris around Earth's atmosphere, especially in low Earth orbit, which will be discussed on the next slide. Kessler developed this theory because he was increasingly concerned about the space pollution, and the focus for his theory is primarily on Earth's satellites. Specifically, Kessler's theory states that the rise in the number of satellites in low Earth orbit may eventually become so great that collisions between satellites will inevitably occur. Thus, the Kessler effect details the chain reaction that will begin once the number of satellites reaches a critical mass. For example, once these satellites pass this point of critical mass, they would continuously splinter into numerous fragments, colliding with other satellites which would then also splinter, and so on. Ultimately, the debris caused by each collision would then render Earth's atmosphere impossible to navigate. Now, most people would not immediately recognize the significance of this event. However, there are serious implications if the Kessler effect was to occur that would affect every individual on Earth. While there are many important satellites within low Earth orbit that the Kessler syndrome could potentially affect, a key satellite system that affects both commercial and non-commercial sectors across the world is the Global Positioning System, otherwise known as GPS. GPS is composed of approximately 31 functional satellites that are maintained and operated by the U.S. Air Force. GPS's most common use is thought to be for navigation. However, it also provides precision timing for many technologies such as computers. This precision timing is set through atomic clocks that are synchronized to each other within an accuracy of a nanosecond between each. This synchronized time provided by the atomic clocks in these satellites allow many critical infrastructures to function, and this will be discussed later on in detail. This next portion of the video will address the consequences and impacts to infrastructure if the Kessler effect were to cripple GPS satellites. The loss of GPS satellites would cripple many commercial and non-commercial divisions, such as the military sector and agricultural sector. For example, the military sector would be unable to communicate effectively, and their ability to fix the GPS system would be significantly hindered as a result. The commercial sector would also be significantly impacted. For instance, the agriculture sector heavily relies upon GPS systems to map fields, roads, and irrigation systems, and to help in the application of fertilizer and chemicals. The implementation of GPS has also increased food production as well as improved the time in which farmers complete critical tasks. Thus, a loss of these satellites would greatly impact the industry, causing food production to plummet partially due to the loss of increased production capacities. Other commercial sectors that would be impacted by the loss of GPS satellites would be in the transportation and telecommunications divisions. For instance, within the transportation sector, the air industry would be severely impaired if a loss of GPS technology occurred. As outlined in a declassified report by U.S. Homeland Security, GPS is crucial for pilots to determine their location while in flight, to navigate their planes, determine their fuel usage, as well as to talk with air traffic control. The loss of GPS capabilities would jeopardize the safety of millions of Americans that use commercial airlines every day. GPS is also a critical component to the telecommunications sector. It provides crucial timing data to a multitude of technologies such as computers and phone networks. The phone networks rely on its precision timing to keep cell towers synchronized so calls can be passed between them. These cell towers would be unable to receive an accurate timestamp between the calls, thus dropping them. Additionally, TV and radio broadcasts rely on satellite signals to receive and send data. If satellites went down, much of the broadcast would be unable to send and receive data to their viewers, leaving many people unable to receive important news during this time. Now it's time to address how you can help the situation. As stated previously, the loss of GPS satellites would cripple many commercial and non-commercial divisions. This issue will need to be addressed by both private and public entities worldwide in order to produce a potential solution to the space pollution issue. World leaders will need to come to a consensus on ways to clean up the space debris that pose this risk. However, it will also be up to the public to place pressure on these leaders to hold them accountable for following through with these potential solutions. One way you can take action is to place pressure on government officials by writing letters or calling your state legislators. By making these government officials aware of this issue and holding them accountable, this will increase the demand for a solution to the space debris issue and ultimately prevent the Kessler syndrome from happening. This video was created for a Composition 201 class in December of 2021 that was taught at Dakota State University, and this particular course was taught by Dr. Haley Larson.